And
Ladies
we went
and
live.
gentlemen, we are live.
We're going to do the intro, but Florida man down there has ruined the karma of the show this morning already. So we just hit the button. Don't do the fancy stuff.
So good morning, everybody. Welcome to another edition of Coffee and Ham Radios. In today's episode, we're going to talk a little bit about we're going to talk a lot about dipole antennas. Reason we're going to talk about dipole antennas is they're kind of the reference. So when you think about how antennas measure gain, they do it in comparison to a dipole or an isotropic radiator, which is a dipole in free space, essentially. Well, it's not really a dipole. It's kind of it's a dot in free space that radiates omnidirectionally. But that's besides the point. In order to facilitate this conversation, we have the saddest of hams, Whiskey Tango 1 Whiskey, Jim.
I'm not sad. I'm smiling. This is me laughing.
And then we got our friend from Florida, Ziggy, down there, who is antenna aficionado and all-around good guy. Chuck and T.O. are in traveling, right? T.O.'s on his way to Huntsville. He wants to be the first one there. Make sure he gets the good spot.
Pretty much.
And then Chuck is playing sleepover with some of his buddies out in California. Is that right?
I think they're Easy Rider Day or something today. They're going to ride their motorcycles.
Putting on their leather outfits and riding around on the motorcycle. No offense to anybody who puts their costume on to ride their motorcycle.
I hope he got pants on. I'm saying Chuck could forget the pants part.
Well, he might have just the chaps on, right?
Yeah. Big John, you ain't that late, son. You're actually kind of close to on time. We're still in the BSing phase.
What's up, Big John? You got anything you wanted to talk about before we get started over here, Jim?
No, the only thing I wanted to share with all my ham buddies, which is unrelated to ham, I just thought it was the most hysterical, stupid thing I had ever read in my life. I shared with you last night.
This is about the British people.
The superintendent of the London Metro Police said, and I'm paraphrasing, obviously, but he said, all you wankers over there across the pond, I can't do his accent, they're going to start arresting American citizens and extraditing them to England for us talking mean about British people. And I said, well, bring it.
We said to cut the poppycock.
He said, y'all quit trash talking us, or we'll extradite you to the UK and prosecute you for talking bad about people and being mean. And I'm like, son, we went through this once, and it did not work out well for y'all.
We went through it twice. Keep in mind, we had a signed treaty. Right? We had a signed treaty with the British, and then they pulled the 1812 war.
That's right. I forgot about that one.
I don't forget about that.
Your asses have been kicked by us more than once. I mean, there should be like 2 boot prints, one on each cheek, firmly planted there. So you bring it there, London Metro PD guy. I just was like, It was either the stupidest or most arrogant thing I have ever seen in my life. And I was like, what? Get out of here. Yeah. Okay. Sorry, rant off. Good morning. Glad to be here.
What you got going on down there, Ziggy?
Playing with dipoles and playing with OBS at the same time and getting my butt kicked by both. However, I did have a live little skit I wanted to do on the stream today as we get down into the deep and dirty of this stuff. So when we get there, we get there.
You all dried out?
Yeah. Can you tell?
I tell you, I was watching on the TV, and some places they had some pretty deep water. It was mostly I think in the Carolinas though.
I had my power lines down in my front yard. That was exciting.
You can't go out there.
And oh man, are you kidding me? We're golf carting it.
Go cut a piece. Go cut a piece for some antenna.
It was a great time. They restrung the line probably in about faster than I can brew coffee. I couldn't believe how quickly they can just get in a truck, yank the line up, hit the fuse or whatever, and then they were gone. So
they are saying that your mic is a little low, so
it's always a little low, guys. I'm sorry. I can fix that, or 8 can do it.
Let me see. There. Oops, that was the mute button. Wrong button. You're up all the way in StreamYard.
Let me I've got one more trick up my sleeve here.
He's got some tricks up his sleeves, folks.
Yeah.
Normally he doesn't have sleeves.
I turned off my wall fan and my monitor like turned off for a second.
So I ordered a whip antenna. They were on sale on AliExpress. 15 bucks for a 17 and a half foot or whatever they are. Those metal whip antennas. And yesterday I get an alert saying it's been delivered. I go out on the front porch and there's a little package out there. Inside the package is an LED strip of lights, a oil filter replacement kit for a DB Cooper Mini, and then these things you stick in your nose to stop snoring. Right. And so I'm all bent out of shape about it. They don't have anything. Jim thinks it's a little funnier than I do. they don't have like a way
drinking coffee.
It's not like Amazon where you can just be like, yo, I want to return this shit. It's different. And looks that's right. Joe saying I got played. I think I did. I'm out $15 and I'm upset about it. And like, what am I going to... Maybe I should call the British Prime Minister. What am I supposed to do in a situation like this?
Yeah, really. I mean, you need to call the Chinese Prime Minister and tell him you're going to extradite AliExpress to the United States. Or send you the wrong crap.
Well, the snore things look like a medieval torture device. They're just like clear plastic. They're not.
What are they? What are they like? Pinch your philtrum or something? Your septum?
Dude, I don't know what they are. I just was like, I was like, what the fuck?
I mean, I haven't been sticking anything in my nose recreationally since like the '80s, but
yeah. So I was a little bit.
Okay.
Listen to me on the Temu app. Maybe, yeah, I guess I would have been better off ordering from Temu. I never thought that would be the case, but...
Bob said run a charge back on your credit card. That's true. They respect the charge. Man, the credit card police will mess you up. That's right.
I paid with PayPal.
You boned. I don't know if they'll charge back like the credit card police will.
Let's start talking about dipoles. So we do have some slides today. So sorry, people who have ADHD. We have dipole antennas, and I put in here Newham's looking at an antenna solution are often overwhelmed by the vast number and styles of antennas on the market. Choosing the right antenna can be intimidating and confusing. Many hams start off with simple dipole antennas, which can be a great and easy way to get started. I really like dipole antennas. The one thing that gets me about them, though, is that they generally are single-banded, right? And I'm one of those hams that if I am trying something for 10 minutes or more, I get upset and switch to another band if I'm not having luck. You guys are the same way, I'm sure, right?
Oh, yeah.
Yep.
But the thing about dipoles is that they're really simple to build, and all antennas are really based off of the dipole antenna. Now, in the early days of amateur radio, folks actually would just use a single radiating wire, and they would just put it right on the radio, run it out to the yard, and no ground side of the antenna. And that's what we did for a really long time. I think it was somewhere around World War I. And some people started saying, well, we need to have this thing be balanced. And that's where they went to dipole type antennas. And then ever since then, hams have been on the constant quest to improve their antennas. Some people still run a single wire out, and that's not a piece of coax connected to a wire. That's a single wire coming out of the back of the radio. But the problem that you have there is that those ground currents need to go somewhere, and they'll often charge your chassis and can cause you some problems there. But I think today what we're going to talk about is a little bit of an introduction to dipoles. We'll talk a little bit about half-wave dipoles. I said we're touching on many topics, which is kind of weird because I don't know if we're really going to do that or not, and we're targeting hams that are new to the hobby.
You're targeting? Are you profiling? Profiling?
Yes.
Did you steal this from a previous video? Go back.
What do you mean?
Go back. This video is...
I don't know.
You bullets? Oh, you outed.
I might have borrowed some of the
You
content
yelled at me for recycling stuff.
Yeah, but you just uploaded, you re-uploaded the same video.
I edited it.
No, you didn't.
And cleaned up the audio. Mm-hmm.
So dipoles are really common, simple antennas. We covered that. And we typically will make a dipole around a half of a wavelength of a desired frequency. So, like if you're going to operate on 20 meters in FT8, you want your dipole tuned to around 14.074. And then there's some math that we can do to figure out what a half wavelength is of that particular frequency. Now, dipoles generally are a little bit more broad-banded, and so you can operate on other frequencies that are close to the tuned frequency. Jim, can you pull up the West Mountain Radio dipole calculator?
Yeah.
I need to take a sip of my soda, so hold on.
Get a sip there, brother.
And then we say we have two radiating elements of equal length. Each one of those is a quarter wavelength in length. And so this would be just a quick diagram. It seems like it's pretty simple, right? So generally we want to have dipoles that are mounted horizontally, and that's called a horizontal dipole. And we'll talk about that and some other ones as well. Hey, Ruben. And at the center of it, I have a little box that's marked CB, and that's not for CB radio, that's for choke balun. And so, like, I'm a big proponent of putting choke baluns on dipoles. I've got tons of videos on my channel to show that, and we talk about it on this channel all the time. I'm not sure how much in depth we're going to get here on that particular topic.
You've got to terminate the antenna somewhere.
Right. So when you mount these flat top dipoles, a lot of times you put the antenna under stress by putting a connector or insulator at the end of the wires and then pulling them taut in either direction. We're going to talk about some other alternative ways to mount them. I typically mount the dipoles in an inverted V, and I don't know if you boys do that or not, but to me it's a little bit easier. And we'll talk about that. But I also want to talk about some of the characteristics of the dipole antenna. So at the center point, we typically have high current and low voltage. And when we feed a half-wave dipole in the center that's mounted a half a wavelength above ground, that's how you get resonance. We're looking at around 72, 73 ohms. So you're going to have an SWR of 1.5. People say, well, if SWR is not 1-to-1, how's it resonant? Resonance is anywhere on the equator of a Smith chart when you're, that's probably a goofy way to say it, but resonance means that your reactance is canceled out. There's no inductive or capacitive reactance. You just see purely ohmic resistance. And resonant antennas can be a good thing, but there are cases where resonant antennas don't radiate very well. So it's not the end all be all. I think in the case of the dipole, you do want them around 72, 73 ohms. Also, your points of high current are the areas that radiate the most. So most of your energy or current that's coming off your antenna is going to be towards that center feed point.
Now, when you talk about a basic dipole, you're talking basically a single wire.
A single wire.
Single wire. You're not talking something like crazy people do and use 75 ohm coax for your legs, or
actually, a lot of people talk about using 75 ohm coax on
as the feed line, or
as the feed line.
As the feed line.
Because if you have it at the right height, you're at about 75 ohms, so you get a really good match from your coax into your radiating elements.
Into the elements.
But you still have the 75 ohm to 25 to 50 ohm translation at the radio input. Now you can beat that with the tuner like I've got down here.
Right.
Or the other thing is that you could potentially beat that with you could build like a 1 to 1.5 balun or unknown and put it at your radio feed point
To do the match.
Right. And so the thing is that if your antenna is 72, 73 ohms and you're using 75 ohm feeder, then what you have is you don't have a reflection at the actual antenna feed point, and then your energy transfer mostly goes into your antenna, which is can be a good thing, right? And
so if we don't have good energy transfer into our antenna, where does the extra energy go?
It burns up as ohmic heat generally.
What?
Or it burns up as heat because of ohmic resistance, I should say.
I thought it bounced back and forth and then amplified your signal.
According to the one guy, it actually regenerates more power and makes the signal stronger.
It somehow multiplies it.
So I can take my 20-watt Xiegu and get a kilowatt of power out of it.
You know, you make a video on a Xiegu, and half the comments are people telling you that you pronounced it incorrectly.
Dude, I don't know. I just randomly pick a pronunciation every time. Xiegu, Xiegu, whatever.
Well, you know, I got it on a video I did yesterday where
I'm not judging you on your pronunciation in this case. I'm just saying.
Yeah, well, some people were getting upset because I was saying radio oddity, and they're like, no, you know, and they get in an argument with each other about the right way to say it. The only thing I can tell you is that I've been working with them for like 7 years, and they've never once come back and told me that I'm pronouncing it incorrectly. The only people who take umbrage with the pronunciation are the unwashed in the comments section.
Umbrage.
How's my audio, by the way?
You sound fantastic.
I sound fantastic. I do want to mention something that I learned about dipoles is that I'm a big proponent on talking about the radiating element versus the non-radiating element. When you have a standard dipole like what we're looking at here, if you follow your center conductor from your tuner all the way out to the field, one of those legs is connected to that center conductor, the other side is connected to the shield. And what I've learned through some modeling software, if you don't use a true balun, if you just use a choke
My buddy
balun.
Jerry's got it right there.
That's right.
Did he cut me off already?
No, he's saying it's really pronounced Zygu.
Okay. So if you don't use a true balun, like a voltage balun, now I say true balun, voltage balun, we don't voltage balun one-to-ones are not very common. And in fact, they are lossy because they are doing transformation. But what you have is you have one leg of your dipole that I want to believe is, I think it was like 30% more active than the other half. Now, in the grand scheme of things, that doesn't matter. I just want everybody to know that there is such thing, you know, because there are a lot of new hams, and this drove me nuts for a long time, is that we have one element that's active and the other one that is counteractive. And the driven side actually has more energy on it than the non-driven side.
Yeah. So when I tune a dipole, to your point, Ziggy, is that I would always cut both ends the same, and then if I had to cut more off, I would cut the same length off of both sides. One of my buddies, Thump, was showing me, and I think you even did the same thing, Ziggy. Like where if you cut the side that's connected to the center conductor, it will adjust the bandwidth more, and if you cut the side that's on the shield, then it adjusts the SWR more.
If you tune the non-radiating side, the shield side, if you make it longer, I had to ask an AI what the hell this phenomenon was called, and lo and behold, I wasn't crazy. It's actually called loading, everybody. Loading the antenna. So if you have a longer shield side of your dipole, you can actually load the antenna and change its impedance. And I'm going to show an example of that shortly.
Awesome.
Yeah.
Let me cook down a couple slides, and then we'll get to your real world example, because I think you cover this stuff in your live demo. But some other examples is that sometimes folks will mount a dipole as a sloper, and that might make it a little bit easier for you to put one up in your QTH. If you don't have space, or if you can't tie the two ends to two different things to put the stress on there, you really just have to tie maybe the center and make that load bearing, and then you can maybe tack the arms to different things. What I always do is I actually mount most of mine, like the diagram on the right-hand side, where it's called an inverted V, and that's where you have your legs of the dipole coming down towards the ground. Once you get past 45 degrees on each side, so you start to become more acute in your antenna angle at the top, the less performance that you're going to get. But as you pull those legs down, the more omnidirectional your dipole will get. So dipoles are directional. We'll take a look at a couple of modeling pictures that I did. But when you pull them down, it makes it more omnidirectional and more round. And for me, it's a lot easier. So I just put a mast up out back, and then I just hook my center mount point to the single mast, and then I pull the legs down towards the ground. It makes a heck of a lot easier. Now, this gets difficult when you're talking about 40, 60, 80, 160 meter dipoles. But for like 20 meter dipoles, even up to 40, it works really well. And I did want to talk a little bit about some other types of dipoles that we see, which are multi-banded dipoles. I'm not really a fan of fan dipoles, but some folks are. And so fan dipoles are when you have, say, you have flat top dipole and an inverted V on the same one. The line's cut for different frequencies. So maybe you have a 20 meter inverted V and then a 40 meter flat top. One of the things I don't like about these antennas is I find that you do get interaction between the wires, and that can affect your radiation pattern. But hams being greedy, we like to have antennas that can operate on as much spectrum as possible, and that's what makes these popular. A lot of times you'll see fan dipoles with 5 different bands on them, which is pretty cool. Hey, Country James.
Country James.
And you'll see 5 different elements on them, and they're really handy. But when you tune those, it can be a super duper difficult task.
Do you want to look at this calculator thing there?
Yeah, why don't you pull that out?
Okay. Country James has been a member for 2 months. Thank you. We met him at, where did we meet him?
We
At
met
Orlando?
him in Florida.
Florida. Where did we pick up Ziggy at? I
We
feel
were
we
trying
must
to
have been
pick
in
up Ziggy in Florida.
In a dive bar somewhere? Okay.
We met Ziggy through what is it? Is it it's KI4 PD KD4
Yeah.
PDI?
Oh,
KF4?
yeah.
Fun with
Jersey
KO4
Mike.
PDI.
Yeah.
Yes.
Jersey Mike.
So we have this calculator. This is at West Mountain Radio, right?
Yeah.
And you can see here we got a little diagram of our antenna, but we can put in frequency. So let's put in 1404074.
Oh, look, I already did that.
All right, and then so when you calculate it, the diagram shows you have L, which is the total length, and then you have the element length, which is E. And this is telling you, hey, for that frequency, you should be at 33 feet, 3 inches. Or each side 16 feet and 7.6. So if I was building a dipole, I would probably cut those at about 17.5 feet and tune down, because every installation is different depending upon height above ground, the composition of your ground, and the wire.
The wire. Mm-hmm. Because
So
that'll
did
be
one of you
your
boys want to
velocity
talk
factor.
Yeah, so there you go. You brought it up. You want to tell us, explain a little velocity factor for us?
Well, so the RF does not travel through the wire at the speed of light. So velocity factor is a percentage of the speed of light that the signal actually travels at. And depending on the composition of the wire, the insulation on the wire, the thickness of the wire, what you had for dinner last night, the
Right.
velocity factor of different wires is not all the same. Generally, everybody kind of wags it at 66% of C, the speed of light. Some cable is a lot faster than 66%. I don't know that I've ever seen anything that's slower than 66%. But
Well,
Steel wire.
Steel, okay, I don't know. Yeah, but so the VF on every wire is different, and those numbers are probably based on doing it at 66%. So if you have wire that's hot and fast, you may have 95%, and you don't need the antenna legs to be that long.
Yeah, and
Or
typically
you
it's
might
the
have
jacket.
crappy wire and need them longer.
Right, it's
the
typically
jacket.
the jacket of that
Yep.
slows it down. PVC and silicone are two of the ones that slow them down pretty good.
Yep.
The other one is, so you mentioned steel wire, and a lot of people are like, I use steel wire, boy, because I'm the man of steel.
It won't stretch.
Man, that's 200 feet for $7, man.
Well, the thing is that steel is not as good of conductor as things like copper.
Right.
Right. And so you do have an issue there, right? Whether you want to accept that issue and move on, which plenty of people do with no problem, it is not as good of a conductor.
Yeah.
Morning, Steven.
My very first antenna I ever made was a inverted V for, I want to think it was 40 meters, or maybe it was 80 meters. No, I went straight to 80. Yeah, my very first antenna was a 75 meter antenna, and I used that what did we decide it was? It was picture wire.
Yeah.
The 200 foot of picture wire. I made an inverted V out of that, and that's how I learned about common mode. Because when I would key up, I would tingle.
You're like, wait a minute, something's happening. Chris
All right.
Bricker's asking about, oh, here we go. What about the terminated folded dipole? So we ain't getting into all the terminated folded dipoles. This is going to be dramatic. I am not a fan of any of the terminated stuff. And the thing is that on your antenna, you have a big resistor that gets hot. And what that heat means is that it's energy that's not being radiated.
Are we talking about at the end where it shunts to ground?
Some people will do
talking
that,
about?
and then other people will fold them back like almost like a loop and connect the two legs together via a termination resistor. And to me, it's wasted energy. But if that's what works for you in your location, God bless you. But I just am not a fan of it.
Well, I mean, yeah, I agree with Ape on that from the science perspective of it. Absolutely. You're wasting juice into the resistor, into the terminator. But also, like Ape said, whatever floats your boat. Philly Ed has been a member for 26 months. Thank you, Ed. And also thank you, Stephen Reynolds, who's been a member for 12 months. And we got some questions queued up in the star, and I'm getting behind on comments. And Shane, our buddy Shane, Adventures in Blind Videography, dropped a
Howdy, Shane.
$4.99 super chat. Good morning, Shane. How are you? And I think that's all the announcement-y stuff I had to make. And then our Brazilian buddy.
Hey, Raphael.
Raphael has dropped what I think is a more complicated way, but whatever. Raphael apparently likes math.
He's an engineer.
I know, and he's still cool. But
He's teaching us about this new metric here called bald eagles.
Yeah, we use bald eagles and Miller Lights when we do our calculations.
if you want a 10-band dipole, divide by 2, you have 5 meters of wire. Yeah. So far, you're still talking in American there, Raphael. Then multiply by 3.28 to get how many bald eagles of wire. What's 3.28? Is that the amount of Miller Lights to be drunk during this process? I think
right,
it
how
is.
many it takes to actually cut the wire.
Right.
Not accurately, just cut it.
Just to get it cut, right? Thank you, Raphael.
Yeah, I like saying, like, hey, I've cut it twice and it's still too short. That's that's my joke there. All right, Ziggy's got a live action demo, and we
action.
it's awesome that he does this because many people claim to be visual learners. So this should help you out a little bit. Let me go ahead and remove this one, and then we'll put Ziggy in the.
Oh, the
Nope.
clubhouse made it.
Joe Brett, what's happening?
Okay, so first of all, what we have here, if you can see it, everybody, this is Grandmama's rabbit ears, and every time I find one of these, I scoop them up because these things are a blast. I mean, infinitely tunable.
Yeah, they're fun.
configurable. Yeah, they're great. And then so most of them come with this this ladder line, and I still have another experiment I want to do. I want to find out if I can just throw an SO connector onto the ladder line itself and see how it performs to see if this is negative or maybe if this ladder line is beneficial. You know, like a multi-impedance antenna person that I know of. So here's my demo, and this is what really got my brain turned into Jello. So I've got it set up right now as a 45 degree. Let's just call it an upside down inverted V.
An inverted V.
An inverted V, correct. And so we're looking at the calling frequency right now, and we're doing pretty well, right? And here's our Smith chart for all of the other people in the chat. But if we take this and it's good, right? Like this, I don't know if everybody can read this, but this line right here, it denotes 1.18 on the swers. If I go ahead and flatten this guy out,
You can read it a little better now, but it's all you, Ziggy.
if I flatten this guy out, you know, our swers have jumped up to you know, about 1.4 or so. And now, like I was talking about earlier about loading the antenna, the radiating versus non-radiating side, I don't have a choke on this, so we're getting the raw of what you would have, you know, during your early ham days. Now, I don't need to mess around with the antenna too much because I can look at the Smith chart and realize that I'm probably not going to. Chris, let me clarify something for you real quick. I've got some friends that say swers instead of SWR, and I just think it's absolutely hilarious, so it kind of stuck to me.
It's funny. It's
Yeah.
good.
I like saying swerves.
I think we're going to make that official now, Ziggy.
Well, Earl, my buddy Earl that works down at the truck stop, he calls them swerves. So he if anybody has a
go.
problem with the rig, he'll say to you, well, what's the damn swerves on that thing?
Okay, so I'm sitting here and I'm adjusting the radiating side versus the non-radiating side in this flat top configuration, and as you can see, I'm never really going to get it down to where we saw it just a minute ago. It's always going to be a little bit out, and that's the typical characteristics that we can expect out of a 72 ohm dipole. But
Yeah.
But actually, you know, if you think about it, we're sitting at like 1.3-ish right now on the on our SWR chart, which is just a tad bit better than what you would expect at this 72 ohm mark. Because at 72 ohms, we're talking at what, 1.15?
Yeah.
Right. So what's happening here is I'm getting better than 1.5 is here.
I'm sorry, you get at 75 ohms, you get 1.5.
Okay, so 72 we can say pretty damn close in.
Yeah.
1 point. 1 point less than 5.
1.49.
Yeah, something like
Yeah.
that.
So here's our 1.55 line, right? Why are we doing better than this right now? You know, and what I've discovered is what's happening is I don't know if you can see that, you can't see it, but just take my word on it. So here's my radiating side, right? Here's my non-radiating side, and it's longer. It's probably 20% longer. And so what I'm doing is I'm actually loading the antenna. And that's what's changing the impedance of the whole system, is that it has a slightly longer counterpoise. Now, if I go ahead and turn this back into a V, of course I've adjusted the length, but do you see how happy the antenna gets? And it's showing me that I'm a little short.
Not the first time you've heard that?
No, not at all. Not at all. All right, so it seems that we're close to resonance. Boy, it really likes when my hand's near it. So what I'm going to do now is I'm going to change the loading of the antenna.
Good morning, Rancher.
Do you see what just happened there?
Yup. Let me hide Vern's comment.
I'm getting stomped on there. Do you see what
So
happened?
it made it look longer, right?
It made it look longer by adjusting the non-radiating element. And so now I think I can shorten this up just a touch. Look at that. I mean, it's pretty great. And as I look at it right now, my radiating element is probably 10% shorter than my non-radiating element. So if you guys... Go ahead.
I was gonna say, so essentially what you're doing is that you're moving the center feed point to an off-center feed point, right?
Correct.
All right.
That's one way to look at it. But I think this is great. So if any of you are struggling to get your inverted V or whatever, banging hot on 3.9, just add a little bit, like 5% of wire to your non-radiating side of your antenna, and I guarantee it'll.
And so when you also what you're getting when you get that V in there is that you're getting a higher Q value, which is basically an efficiency rating for the antenna. And it should perform a little bit better because what it's doing is it's stopping you from picking up stuff that you might not want to hear. So like if you look at like a loop antenna, like a mag loop, they're super high Q and the noise is generally lower because they're picking up less stuff. When you have a more broadbanded antenna, you're picking up more stuff and it lowers your signal to noise ratio. Vern had a question about that's 100% hertz. Had a question about velocity factor, and he was saying, where do you figure this? I think he's asking, where do you figure out the velocity factor on manufacturer sites? What I can tell you is that most of the wire that I use doesn't give you a velocity factor because I think most people don't care, except for ham radio type folks. So sometimes if you're buying wire that is specifically designed for antennas from an antenna manufacturer, they will tell you the velocity factor. But if you just go up to like Home Depot and you pick up some THHN wire,
yeah. Yeah, well, so
good luck finding the velocity factor.
if you go to ABR Coax, for example, there's a link below, by the way. They're a show sponsor, good friend Chuck over there, and a code. If you go to ABR and look at coax, you'll see velocity factor on the different coaxes. If you go look at Messi and Poloni or DX Engineering or any of the other vendors who are selling ham radio coax like Ape is talking about, they'll generally give you a VF. And also somebody made the comment, Cyber Jason, I think a little while ago. Yes, coax is going to be slower than a single wire. A single wire VF will be a lot higher. But like Ape's saying, honestly, it's so close, it just cut it a little long and then trim it back until Jesus comes and everybody's happy.
I want to clarify something. We've got a gentleman by the name of Jerry.
Be careful, man. Jerry likes to tango. I can tell you that right now.
Great
guy.
I just want to clarify something, Jerry. So when I talk about the radiating and non-radiating side, I'm using simple terms, right? Now we all know that there's a theoretical side to antennas, and then there's the actual physical, ABC side of antennas. So when I say non-radiating, I'm referring to whatever leg is connected to the shield, and I think we've all established that. However, I am going to agree with you, Gary, because I'm not disagreeing with you at the same time. I'm just trying to keep this as simple as possible. We have our center side and we have our shield side of our antenna.
Yes.
And this one's more of a question for you, Jim, because you've actually done this, right?
Yeah, I did. You can use an oscilloscope and figure out velocity factor on a wire.
And I believe you can with a nano VNA, but the
Yeah.
thing
Well,
is
yes. Yeah.
the thing is that the velocity factor calculations require you to know things like length, right? So if you have like 100-ish feet of something, you have to get out there, tape measure, and all that other stuff.
If you do,
I just cut it long and then trim it to where it works,
Yeah.
and then I save myself the slide rule party. You know what I mean? But
I always have my slide rule with me at all times in case I need to whack, a gangster or something too.
and Raphael's saying that it needs to be estimated. He's got speaker wires with 88, 95,
Yeah.
and even 8.
Yeah. And the nano will give you some idea of length, and so will a rig expert as well. And I'm sure other antenna analyzers have that function built in. But yes, you can also do it with an oscilloscope. And there's two different things there you're asking. So you're talking about the velocity factor, which means you need to know the length. If you don't know the length, then you need to figure that out first, which you can do with, I think, with a nano. I'm sure you can. And with a rig expert and with a scope. And then once you have the length, then you can get what your VF is. You also have to have a way to do the thing. But
Were you
that's a
sharing
whole other
anything
show.
else there,
No.
Zig? Did you have anything else
Oh,
that you wanted to
Ziggy.
show and tell?
Yeah, my Nano VNA saver just crashed again.
All right, well, I'll go back to the presentation while you're doing
I've got a
right,
I've got a-
Don.
So we talked about that one, and then this is another type of dipole that's multiband, and those
Yes.
Easter eggs that I've got up on the element are supposed to be traps. So you can build trap dipoles, and when you build a trap dipole, basically what you're doing is you're putting a circuit in line with your elements or your legs of your dipole that will block frequencies. And so you put one in at the 20 meter length for your dipole, and then you add wire up to the other side, and you could go out to 40. So you can have 20 and 40 on the same wire. Now, this is like a little resonant tank circuit with an inductor and capacitor in series. And when you put these in place, you really do lose a lot of your bandwidth. So in an example like this, your 20 meter dipole would be more broadbanded, but your 40 meter dipole in this configuration would have a much higher Q. Not a problem, but you would just need to tune that more specifically than you would the 20 for the area on the 40 meter band that you want to operate on. Does that make sense?
Yes.
Awesome. I suppose I can keep on trucking. So I talk a little bit about a balun or a choke, as some folks call it, and I said the balun refers to a device that's used in the antenna system to match an impedance between an antenna and a feed line. Generally, this is between a balanced antenna, such as a dipole, and an unbalanced feed line, such as coaxial cable. The name balun is for balanced signal to unbalanced, and they're both voltage and current. I think we cover these things on a lot of things. I also talk about chokes. I say they're for reducing common mode current, EMI, or radio frequency interference, and people often refer to chokes as baluns and baluns as chokes. I didn't want to play a semantic game today, but like an example of this particular dipole, if I don't have, and even if I do, but if I don't have a choke at the feed point, this feed line can interact with the legs of the dipole. Because it really does become part of your antenna system, like we were, we were talking about the radiating and non-radiating side. They're all being part of the antenna. The shield on your coaxial cable is the exact same thing. And when you have currents running on the outside of that shield, what'll happen is that it can either pick up or radiate signals that the legs of the dipole might pick up, and it will degrade your signal to noise ratio. You might pick up the sounds of things like power lines that you don't want. And then the other one is that you can get common mode currents that come back into your shack or your radio. Now, some folks will say they're not common mode currents or reflected currents. Either way, there's currents that are coming back and causing you a little bit of grief. I think that Ziggy was talking about the time he was getting tingly fingers when he was keying up from current coming back and really essentially looking for a low impedance path to ground. And that can be you, or it could be other devices in your shack. So like when I was getting into HF antennas and before I was really using chokes extensively, I would have problems where my laptop would freeze up when I was transmitting FT8 because I was having RFI or common modes coming into my shack looking for that path to ground, and it was coming in through my radio, through the USB cable, and right into my laptop. Once I choked that, it stopped. So I did want to talk a little bit about that stuff. And here's a little bit of an example of what happens with your dipole antennas.
Conductors.
Yeah, and what you can see is that you have current, which is like a L1 current coming out or coming in on arm 1, which is connected to the center conductor. And then when you have current coming out on the shield side, what happens is a transition from your coaxial cable into your dipole. And this is the same for end-fed half waves or off-center fed dipoles, or really just about basically any antenna, is once it goes to make that transition from the coax to the element, or to the shield, arm 2 in this case, that current is looking for that lower impedance path to ground and will do a U-turn and come back down on the outer side of the coax. It's called skin effect. And typically RF travels on the outside of a conductor, and that's why we look at coaxial cable as a 3-conductor transmission line. And let me see if I can go ahead and keep on going here.
Jerry brought up the common mode ammeter imaginary concept topic.
Yeah, he does. And so the challenge is that it's difficult to measure common mode current in an easy way. And sometimes what people will use is they'll use probes on the inside and outside of the coaxial shield. Very specialized probe, very specialized procedure. It's not the kind of thing that just Joe Six-Pack Ham can test or measure. So what folks do is that they'll clamp an ammeter onto a transmission line. And then what you'll see is that when you transmit, you'll have currents that are being picked up by the ammeter. Now, if you put a common mode choke in line, the currents that you're reading with the ammeter go away. And some folks debate that as you're losing power or you're losing, potentially radiated signal by doing that. What I can tell you is that I've witnessed problems that are described as being impacted by common mode current, installed a choke balun, which has this specific use case of attenuating those common mode currents, and then the problems I was having subsided. And then if you put a feed point, if you put a power meter in between the choke and the transmission line that goes out to the antenna, you don't see a degradation in power. So that's as far as I'll go with my testing. I have not probed the inside and the outside of the coaxial shield simultaneously and done a differential comparison. So in this picture, this is an early antenna that I built, and I just wanted to, on this channel, we like to get folks building their own antennas, whether it's from scratch or from a kit, and working on their own antennas to improve their overall experience and have more fun with the hobby. And this actually looks terrible in my opinion, but the reason I share it is that, early on I was able to build a dipole antenna that was relatively cheap, and I was actually able to learn stuff and have a lot of fun when I was doing it. And so that's just an FT140 mix 43 toroid, so it's not even the best one to use for choking. But when I was having those problems with the common mode current, I wanted to put together a dipole antenna, and this is what I had at the time. And that's actually speaker wire that's wound around there. And I got a lot of grief about using speaker wire because it generally isn't capable of dealing with high temperatures and things along those lines. But it actually worked really well, and even though there may have been loss in there, I don't know, I didn't test it, but I had a lot of fun with it. And the point is that relatively inexpensively, you can go out and build an antenna and have some fun. Now the center
nothing.
The centerpiece that I have here is actually a 3D print, and it's was designed by Kevin Laughlin, and he's a ham. He's the old ham guy.
Yep.
Pretty popular channel, nice guy. Knowledgeable fellow, but that was his design. I don't want to say I designed it, but I just printed it out and then just wired all this up and was able to go out and have some fun in the backyard. So speaking of skin effect, the surface roughness can affect the skin effect. If any of your books, Professor, is the effect of surface roughness on a radio signal? I have no idea.
I do.
Fire away.
Okay, accidentally discovered this one. Poor white trash Palaka boy over here trying to make a quarter wave dipole, and I used all thread. And then when I scanned it on the, on the analyzer, I was like, "What in the hell is going on here?" The entirety of the 2 meter band was like all under 1.1. I'm like, "What is?" And I'm sitting here. I knew what it was. That all thread has two different diameters. It has a maximum diameter and a minimum diameter on the inside of the threading. Do you follow me?
Mm-hmm.
Yeah. So basically, I just made this insanely broad-banded quarter wave ground plane, elevated radio ground plane. And now you can look at that two ways. I look at it in the way of usability and what's another word I could use for that? Ease of use, right? Or you can look at it, in some people's way of looking at it is that it's a lossy antenna. So the choice be yours, but I'll take usability over a few decimal points.
All thread.
So to get back to that,
All thread. I mean,
Yeah.
fun. That's
What?
awesome. And if you get into a fight at field day, you can kick somebody's butt with a piece of antenna. I'm just saying.
You could fall on it and die. Yep. So
Do a biker fight with it.
So he's talking about the roughness or the texture of the radiating element that we're using here. So of course, if it has variations of it, it's going to change its characteristics as far as bandwidth.
All right, let me add
That's
this back
interesting.
in.
Leave
This
it to
is
some
right.
guy in Florida.
So here's some radiation patterns I wanted to show here, and these are 20-meter dipoles, and this dipole is in free space, and so you can see that we have two lobes when we're looking down on it, which is the left-hand side, where we have radiation maximums and minimums. So along the ends of the dipole are where we have those deep nulls that come in towards the center of the circle. And then on the broad side, which is the length side of the antenna, you have these larger lobes where your radiation gets out. And this is an example of a dipole in free space. And basically it looks like a vertical donut. And that would be the radiation pattern. Now we really can't have a dipole in free space. I suppose you could argue that you could have a dipole 2 miles up in the air, and that would be as close to free space as we could probably get. Probably need some pretty big trees to do that. So we will typically mount our dipole at a particular height above ground. And when I look at this one is 10 meters in height. So it would mean that it is at a half wavelength above ground. And you can see those nulls on the side are lessened in impact. And then you can see north and south on that circle, we still have our strength, our strongest period of our lobes. So you can use azimuthal maps that actually give a flat Earth projection of the known world, and you can use those maps to position your dipole that it will radiate into the areas that are most of interest to you, right? So like if you lived in California, you might want to point northeast, and you would get large swaths of North America that way. And then you can see the elevation pattern on the right-hand side where you have your higher trajectory takeoff angles are around. I can't see. It's so small I can't read it. But you can see where those lobes stick out the furthest is the takeoff angle, and that would be where your strongest signals will go up and then refract against the ionosphere. And then here's kind of what that radiation pattern would look like if you can imagine that sitting out in your backyard.
Bubblicious.
Yep. And then if you mount your antenna too high, and mounting them too high and too low can cause all kinds of different problems. This is 15 meters in height, so it would be 0.75 of a wavelength off of ground for that same. All three of these charts are for the same antenna. And then when you see from the top-down viewpoint, it's similar. It's really similar to what we had at a half wavelength off of ground. But if you look at your elevation, you can see your takeoff angles are a little bit lower, so you would probably get further DX because the refraction angle off the ionosphere is more obtuse. But you have a tremendous amount of energy going straight up into the air. In this case, even though it's high off the ground, you would still get NVIS type characteristics from your dipole. And this is what that radiation pattern looks like. And so unless you're really working NVIS with other people who are close by, most of this energy that is in that upper light bulb looking thing, or maybe it's like a hot air balloon like our friend Shane rides around in, that's really just going to be wasted energy at that point
That's
in
the
time.
cloud warmer.
Right, it's 100% what it is. And again, I talked a little bit about this. And I just wanted to throw, this is my last slide, is I really just wanted to throw a comment in here that hams are faced with the decision to build or buy a dipole. Neither's right or wrong. So if you buy a dipole and you're out there having fun, awesome, man. If you build a dipole, that's even awesome too. And if you build it from a kit or from scratch, either way is fun and rewarding. Kit building is actually a great way to get started because you have all the parts that you need and typically can get some support if you run into a problem. Buying's quick and easy. You may get some vendor support. You do pay more for that convenience. Dipoles can be easily built with materials you may have on hand. It's an educational experience. It can be very rewarding, and you may save a buck or two. Building versus buying is significantly financially different.
Yeah. So the other thing that I would mention, along with what Ape just said off of his slides, was if you build or whichever you do, that's fine. You're in this to have fun. It's not an argument about which is better. I mean, I know I have a DX Commander and these dipoles are ganky compared to my DX Commander. Who cares? No one cares, right? I mean, some crazy old men might care, but it's to have fun. And you know, Izzo always says this on the Clubhouse, and Izzo goes off on a lot of topics, but on this one, Izzo is dead on. It's, you know, if Ziggy wants to make a 2-meter antenna out of all thread, rock on, man. Because you could probably get that through TSA. It's an antenna, you know? And there's not, with something like dipoles, or a lot of these antennas, there's not exactly a right or wrong. You know, it's going to work to some extent. Some modifications will make it work a lot better, but
Well, a lot of dipoles
still
get
gonna
bad
work.
reputation, though, right? Which is kind of a shame.
Do what now? Say it again.
Dipoles a lot of times get a bad reputation. Like, people don't want a dipole antenna in their arsenal because they think that, hey, it's only single banded and it's a cheap antenna and, you know, it's very basic. But in that basicness, there's simplicity, right? And that kind of makes them elegant. They perform really, really well. And so while you might not get the multi-banded experience that you're looking for, there's something to be said for using an antenna that's actually tuned for the frequency that you want, as opposed to using an antenna that's tuned for a frequency different than what you want, and you're relying on a harmonic relationship to that tune to another frequency that you want to use. What I would say is that right now is a fantastic time to put together a 2-meter dipole. You don't have to get them very high up in the air and go out. Did I say 2-meter? I meant 10-meter. Dipole, you don't have to get them very... Yeah, I meant 10. You don't have to get them very high up in the air. We have great solar conditions right now, and you can have a lot of fun and make contacts in areas that you did not expect.
I've got a hot button topic that I want to bring up.
You need to hurry because I got one that's just... It's
All
like
right,
I
then
got
you
to
go-
pee almost.
then you
But
go first.
No, go.
Okay. No, mine's going to take too long. Go ahead.
Okay. Real
What you
hams
got?
do whatever the hell real hams want. If I don't feel like building a freaking antenna, I'm going to go buy a DX Commander. That annoys the ever-loving crap out of me, and it violates the fun rule. Sorry.
Well, real hams use manual tuners. So just
Oh,
get that out of
God,
the
there
way.
he goes. I knew that one was going to come up.
But
Real
the
hams
thing about
do
the-
whatever they can do to play radio.
The DX Commander's a kit, right? And so
Yes, it is.
there's a building component there.
I did build it. I cut some wire and made the pole bigger.
So
Not the
when I
first
was
time I did that.
when I was a new ham coming up, and you know I'm stuck to to the basics and the fundamentals. I'm looking at a quarter wave ground plane, right? And then I'm looking at my inverted V dipole, and I'm thinking to myself, what the hell's the difference?
Big John. You keep going.
Did you guys follow me?
No, say it again.
Say
Okay,
it again.
so-
I'm sorry. Neither one of us were paying
So
attention.
so I'm a young ham, and I'm making my first quarter wave ground plane, and then I've also got my inverted V in the back field, and I'm trying to figure out, you know, what the hell is the difference in between the two, because I can model it here as a quarter wave, you know, with a single
Right.
counterpoise. Wait a minute, all of a sudden now this is an inverted V? Like, what? Did I just change the angle 33%? Like, what? This drove me nuts as a young ham. I'm like, what's the difference in between a dipole and a single counterpoise quarter wave? There's not much.
Yeah, well, the big thing is the relationship to the ground, right? And that's probably the biggest thing. I was watching a video the other day, and this guy was using a 17-foot whip, and then he was using a tuned radial, 17-foot radial that he was mounting the whole thing 3 feet above the ground, and the guy was absolutely killing it. And I was like, I'm gonna have to play around with that a little bit. And that's when I ordered my 17-foot whip off of AliExpress, and I got the LED light and the snoring plugs instead. So a little bent out of shape about that. Let's get you on the big screen, Ziggy, because you look like you're going to do some splaining.
All right, so let me get my splaining on. What we got here is an image that was sent to me by somebody that I got to the privilege to build an antenna for. And he was telling me about his experiments with low height above ground dipoles. Now, there's this little tiny area. There's this little tiny area right here, and this is the star of this graph, okay? Now, typically, these comments are blocking me. Typically, our height above ground is, you know, in wavelengths, and we want to get our ohmic, you know, to where it needs to be, 50, but of course we're going to be a little bit higher in the 72 mark. So it shows us at about, what's that, like a half wave above ground seems to be perfect for a, right? Yeah, half wave
Yeah,
above
dang
ground.
close.
Yeah, dang close. So right there, right at 70 ohms is about the best you could expect. But look down here what he's done. He's dropped his height above ground super low. So we are like somewhere in between like 0.18 of a wavelength above ground. And what that ends up working out to be is about, for 10 meters, it's like 40 inches or something above ground. So this gentleman told me what he's done is he's made just your typical dipole, and he's got it perfectly horizontal above the ground at 42 inches of height. And then he shows me this. And I said, that is unreal. Now, there's another side to this conversation, is that we are radiating the ground, and we're forcing this antenna down into 50 ohms. Does this look great on paper? Yes, it does. Is it a great antenna? I don't know, but the radio is sure going to love it. So, again, what we're looking at here is a dipole that's 42 inches above ground for 10 meters.
Hey, Raphael, we'll post that picture that he was just showing in the Coffee and Ham Radios.
Talking about this one?
Yeah, Discord.
I'll throw it right now.
We'll put it in Toads in the Coffee and Ham Radios section.
Yeah, I'll do it right now.
Chip chop.
Yeah. But anyway, I just thought that this was pretty awesome what he was doing. And again, like I said, just because you're forcing your dipole to be 50 ohms doesn't make it
Awesome.
an efficient antenna, right? You've just forced more resistance onto it with the height above ground.
Liberty Cave saying he wants to test that 25-foot whip ASAP. So, and Michael saying I need to test the 25-foot, the Cha 25-foot whip. And I got to tell you, I want one of those whips, and I want one of those whips bad. But
are you talking about the AliExpress one with the M10?
No, this is the one from Chameleon. And I have a little bit of a moral conundrum with that I've kind of talked about. I'm not the biggest fan of, we'll just say, some antenna companies, because I feel that they overcharge for a lot of their products and overstate the
Efficacy.
The efficacy.
Do you take umbrage at their efficaciousness?
Yeah, and I don't like falling prey to the machinations of the antenna manufacturers. And
We're on a roll, son.
and so I'm not going to buy one until somebody makes a clone, or the people who make the clone that the Chameleon sell, and I'll buy one from them. But I just won't do it.
Their Machiavellian declarations of their efficaciousness.
Right. I find it's malfeasant behavior that some of the manufacturers partake in, and I just don't.
Right.
I just don't want to. I don't want to support it.
I want to go get Grandma's antenna out of the shed where we've stored crap we're just too lazy to throw away, and we don't think we should, but we should. And I'm going to run 1,500 watts through a TV dipole later today, I think, for entertainment value.
I got some antenna oil for you.
Antenna oil.
Just use that to grease up the antenna.
I'm going to set it outside, though. I'm going to put it outside when I do it.
You got to polish it on your radiating element, and it'll get your swerves right.
It speeds up the swerves.
I need more swerves. That's right.
That's awesome.
Abe didn't say Chow was the company, y'all.
No.
I mean, you use your own judgment. But he's right. There's a lot of antenna. It's not just one company either. There's a whole lot of antenna companies.
They just charge way too much money for what they're selling.
It's a wire and some plastic, people. You know? Right. I agree.
And unless you're absolutely, addicted to doing things perfect, there's the time and the work put involved into it. But, even that can be argued by a lot of people.
I mean, Kevlar wire is cool. Do you really need Kevlar wire? Do you expect to get attacked by SEAL Team 6 at the park when you're doing your POTA thing?
Well, when SHTF happens, son, you need to be ready. You
Right.
need to have your mil-spec Kevlar.
Yeah, and your military whip and your green.
Some of these companies do things like, so they'll sell an antenna, right, that people have taken apart and shown to be problematic. But in order to take them apart, you essentially destroy the antenna because they rivet them shut, they super glue, they JB weld it together, and then they fill the box full of glue or foam or something like that. Hey, Rob.
Potting.
And I just think that it's greasy, right? If I'm spending $300 on an antenna, it should be field serviceable.
Wasn't there one we saw recently that the match unit was full of potting compound?
Yeah. Yeah, or like they take that spray insulation stuff and spray it in
The spray
there.
foam stuff, yeah.
That's called smoke.
And it just drives me crazy.
That's called smoke. There's usually
And also, I'd like to
somewhere.
see transparency in the manufacturing. So if I'm buying an antenna from somebody, I should be able to figure out what type of core is in there, what kind of winding, what kind of components that they use. There's that Ziggy box.
And Don, I know it'll take more stress. And if you're going to run a 300-foot or 500-foot antenna permanently, Kevlar's your uncle. That's right. But I don't think you really need that at the POTA. Just saying. And
So
those are sold as, portable antennas.
So this was
What are we
part
looking
of,
at?
This was my first antenna challenge that somebody took me up on, and this is out of another product, and this is a very controversial transformer. I call it more of a presenter than a transformer. Because it always seems to present the radio with a great match, no matter what's going on. So it's really separating the radiating element from the radio, and that's its job. Like that's its purpose, and that's why it's used by people that use it. I went ahead and rewrapped this and did some other stuff. I put it into a field serviceable box, instead of a glued together, PVC capsule. So it is.
I like
now
the quotation fingers on that, Tig.
It is field serviceable now. But anyway, I got some video of me using this, and I could not believe it. I just hooked it to my simulated gutter, and I could not believe it. I was getting out, as far out as Ireland and all over the United States with that crazy thing. So that just goes to show you that, you can get real pedantic about things, but RF gonna RF.
Yep.
So
Well, especially right now with good solar cycle, right? Like you can get away with something that's lossy, or you can get away with something that is not fully optimized today. Like 10 years ago in the solar minimum, you probably would have had some problems. But a lot of these antenna manufacturers design their antennas to present low SWR because that's what we all look at. People don't look at field strength. They don't look at radiation resistance. They don't look at ground losses. They just look at swerves, and then they'll be like, hey, this antenna's great. It performs well. You should buy one. I guess that's my rant on that.
You don't, Don. That box is the beginning of the antenna.
What else we got, boys?
I don't know. We're at an hour. I mean, are we done? Y'all tear this up?
I didn't have any more pictures or anything to share. I mean, I guess we could answer some questions if anybody's got them.
I kind of want to know more about Don's question here. How do you maintain 50 ohms inside that box? What is the actual question behind this question?
Well, I think you're looking at the input of the box at being 50 ohms. The other side's not going to be. It's not going to be 50 ohms, right? And what this thing does is through loss in that core, is that whatever you're hooking up as your element, regardless of the impedance of that, it's going to. It's first off, it's going to transform it down. I think it's about a 5-to-1, right? So if you have 1,000, it would transform it down to 200. But the loss that you're going to get in that core is going to bring it down even lower, and then you'll be presented at around 50 ohms, give or take. And then usually with a touch up tuner. Now with that antenna, they recommend that you use a tuner, right? It's not a.
It's tuner dependent for the most part, but I've gotten away without a tuner on a lot of bands below 40. So 10 through 40, this thing's a dead ringer without a tuner.
We have a Jesus freak over here is saying that the Q is far more important than low SWR. And what I'll say to that is that if your goal is quieting signal to noise ratio and those things, it absolutely is. If you're looking for antennas that you can use broadbanded without a tuner or multiple frequencies, then I would say it's not. Important is a relative word based off of the goals of the operator,
Yep.
right?
Well, yeah. I'm going to rant again if I start talking. I'm going to keep my mouth shut.
Ape, are we gonna do the you and me 5-to-1 build? We got to send
Yeah,
one
at
to
some
Jim
point.
too.
Yeah, you got one going over to Jim?
I think Jim needs one too. Yeah,
I mean, just what?
We're looking
gonna-
at doing a 5-to-1 build.
we're gonna build
Okay.
this crazy trans. I mean, we've built everything else under the sun. We might as well do this crazy thing that happens to work.
The problem is I got to get a big ass soldering gun, right? Because they heat that copper pipe up to solder to it.
Pipe?
Yeah,
Yes.
pipe.
Yeah, I can't do that.
He said, "Yeah, no."
Not in my house, no.
My
I need
Heiko is
a
only 70.
torch.
I got it. Yours is only 70.
My Heiko is only 75.
Oh,
75
there's
I think
your
it's
problem.
75
That tip
watts.
is too small. Don't you have one of those blunt, head beater tips?
I'm sure I got one.
Yeah, that's all you need.
sure I
If it
got
goes to
one right here
70, you're
somewhere.
fine. Because I've got an 80 and I was able to do it. I think that kit makes it
Sound like a
easier
lot of work.
too.
That's what I'm
Right, Liberty Cave's right. So I was thinking about using my cigar lighter because it's like a little propane torch. It's a butane torch, but that might get it hot.
Are we gonna smoke some RFDX
An
pipe?
RFDX pipe.
Yeah.
It's just a little piece of pipe. It's like this big. It's relatively small, but my neighbor's got one of those big soldering irons. It's got like the 1/2-inch tip on it that you plug into the wall. So I might borrow that from him.
I've got an iron around here that I found in the shop, and I asked the old man. I said, "Who did this belong to?" And he said, "The old man that owned the shop before me." And it was a 100-watt iron, and it had a wooden handle and a cloth cord.
Right, that's
From
like the
Radio
ones my
Shack?
grandpa had.
Oh no, not from Radio Shack. This is from some mom and pop's company up in Wisconsin. That's all they did was make these huge irons. And I asked the old man, I was like, "Can I have this?" And he goes, "No, give it to me." And he took it from me.
Pull up, Jim. Can you pull up Harbor Freight? I want to see what kind of big old irons they got at the Harbor Freight. Like if I can just get a monster size 200-watt iron at Harbor Freight for $12,
You don't need a 200, man. I can do it with an 80.
I burn the house down.
So I've actually got, those Wise smart plugs,
Yep.
that you can put around your house. I've got one on my soldering iron here in the house because I went away on vacation for a couple days and I came back and I had left my iron on for 3 days straight.
Ooh, I did that too. That's a damn fine idea because I've left mine on in the shop overnight for a day or two. Yes.
Well, there's
So,
old
yeah.
ones that plug into the wall, man. They don't turn themselves off.
So you can see right here, I've got my soldering station on, and it's on right now. I can turn it on.
Yeah, I got a Weller and it does cycle, so it didn't sit there at full power,
All right, so we're not technically looking for a soldering iron at this power level. We're looking for a wood burner.
What is
There's
it? What is that one that looks like a cigar lighter? That it's on.
Oh,
Oh, well, never
that's
mind.
100 water. There's a gun. Anything you're doing with a gun is cool.
I hate the guns because you're always limited by how tight your
Yes.
heating element is,
And your hand starts cramping.
and then you
You
get
go
the, the
$15.
pistol shakes. Yeah.
I get that butane torch for $15.
I got one of them. It'll work for a while.
See, there's a
guarantee
30
guarantee-
watt lightweight. You don't want that.
I guarantee you, every time you go to use it, it's out of butane. This is what I'm talking about, Willis. Right here. Yep. Bring it.
I don't know if that's safe. Troy Emmel's asking if you can extend a 17 width to 25 by attaching a section of steel tubing or lubing. Yes, you can.
Electrically, it will be connected. I don't see why it wouldn't work.
So they don't have what I'm looking for.
All right. Ziggy said wood burning, so let's try that.
Yeah, you're kind of getting into the wood burning area.
Well, that's the only wood burner they got.
Go to the home.
It's
Home
only 30
Depots.
watts. So that's where I got my 80 watt Weller station, was Home Depot.
If I go to torch,
You can make creme brulee with that torch.
it also is how I sear steaks after I pull them out of the sous vide. It's also how I get rid of weeds. Fire solves a lot of human problems.
There you go. Get that Chicago electric welding station.
I've never welded. Never welded.
Oh,
That's what you need is one
I'm
of
a
those
big
battery
time welder.
welders.
Yeah, I know you are. I've never done it. Never had a reason to. And
Let's see what
I
they got
have
at the Home Depots.
at the Home Depot. And I have friends who weld, so I just get them to do it the 3 times I've needed it.
This is the iron that I have.
What do you want me to search for?
Big ass soldering iron.
Yeah, see the
We'll
the
just
blunt,
leave big
the
ass
blunt
off.
on that.
Yeah.
Yeah, mine came with a little rheostat though, so I can change the. Kind of dial it up. I only get to use it
See, I'm not trying to spend $100 on an iron for
30,
a one-time project.
60. Come on now, where's that 80 at? It's like an 80 station. That might be it right there. It says 60, but they have an 80 watt version, but that's what I have.
This is what I have is this Weller here, the digital station.
Yeah. Another.
I don't know where
60
my
watt
tips would be for
corded.
this thing. I know it came with some because I put the chisel tip on there.
I don't see anything that says 80 so far. There's a 67 watt.
Yeah, I wonder if I should just get a
Whoa,
different.
there you go, 120 watt cordless soldering iron.
Runtime. 2
Yeah,
minutes.
that's what I'm talking about. I don't like the cordless stuff though.
I don't either. I would question the efficacy of their manufacturer claims.
I almost got a cordless DeWalt compatible hot glue gun, but then I came to my senses and I got a corded one. Talk about a serious that's a serious hot glue gun. 85 watt hot glue gun.
There you go. There's a 100 watt Weller. That's $70. Not cordless.
This is what I have right here. So I guess I paid about $72 for it. 20 to 80 80 watt variable. And this is and I had to step up the power to do what I do. I do a lot of blunt soldering of large gauge stuff whenever I build antennas. So how far does my he's asking how far does my DeWalt shoot here? I haven't plugged it in. I just got it out of the box here.
You're muted, Cletus.
That is a formidable glue gun. So Donald's asking, does wire gauge factor in the construction of a dipole? It does. So the bigger the wire, the more broad banded it generally tends to be. And I think somebody was saying that there is a 12 gauge minimum for antenna installations to be compliant with the electrician's code or something along those lines. But I typically use around 18 gauge, 18 to 22 gauge, somewhere around there.
Yeah, Lon had a cordless hot glue gun, soldering iron in the 90s. I bet that thing had a big old NiCad battery pack, right?
Here's Don, cage dipole. So a lot of times when people build dipoles, they'll have multiple wires running both directions and then terminated at the same point, and the start point is the same, and it looks kind of like a bird cage that's been stretched out and turned on its side. And they are much more broadbanded than a single wire dipole. It looks like we're just going to have to go to Hollywood's house. He's got a 200-watt Weller. So we'll just have an antenna building party over at his place.
The hot air station might be a good choice for doing something like that.
You need that flame, son.
That bastard gets I've melted many a PC board playing with that hot air station.
Yeah, I bet. All right, well, I think that's going to wrap it up. I want to say thanks, everybody, for watching. It's much appreciated. Thanks for the comments and the engagement in chat, and thanks to these fellers for being here. With that, I'm going to hit the end stream button.
I did it.
Oh, wait a minute. There's one